This is the walkthrough video for PCTC 2020-2021 round 2, question 11, simple drafts. So this question is an implementation challenge because we essentially need to simulate this game of drafts and then print off the final state of the board. So how are we going to do this? I'm going to represent my grid, my grid as a dictionary. You can do this as a 2D array. There's no specific reason I'm going to use a dictionary. That's just kind of the one I gravitated towards. I wouldn't say a dictionary or a 2D list is faster than the other. They both have their quirks you have to work around. Okay, so let's get started. So the board is going to be equal to an empty dictionary to begin with. Now we have to create the board from scratch. We have to create all of these. This is our starting position of the board, and you have to create that starting position. So let's go through for every x value in the range 1 to 9, because we want to calculate the coordinates from 1 to 8, and then we want to do the same thing for y, because it's an 8x8 board. And I will also say, so the grid we're given in the question uses the coordinates 1 to 8 for the y-axis, but letters A to H for the x-axis. We're going to convert these into numbers just because I think numbers is easy to deal with. And so we're going to assume that A is 1 and H is 8, and it goes up across that. Okay, so for every coordinate in our 8x8 board, we need to figure out what is at that coordinate to begin with. It could either be a blank square, it could be a black square, or it could be a white square. Or sorry, a piece with a black square or a piece with a white. No, it could either be a blank square, a square with a white piece, or a square with a black piece. So how do we figure that out? Well, if it's a white piece, you notice we can kind of see a pattern here, right? So if the row is equal to 1 or 3, and the x values are all odd, then we have a white piece there, right? Because, for example, if you take this piece here, that's row 1, and every alternate square starting at an odd square is a white piece. Same for row 3. And row 2 is just the opposite. So we can implement those conditions here. So if y is equal to 1, or actually, if y is equal to 1 or 3, and x is odd, then we can say that board xy is equal to white. And in our dictionary, the key is going to be the coordinate as a tuple, and then the value is going to be whatever's at that position. So this will work for rows 1 and 3, but we also now need to account for row 2 as well. So we can do that and say, if that's the case, or if y is equal to 2, if we're row 2, and x is this time even. Because if we're on row 2, then all of the even x's have a piece on them. Okay, so that should work. Now we can copy paste that same thing for black, except that we can switch out the numbers. So what are the numbers going to be? Well, if we're on row 6 and 8 and x is even, that's one of them. So if we're on 6 or 8 and x is even, or if you scroll up, if we're on row 7 and x is odd, that's the other condition where this works. So if row 7 and x is odd, then this should be a black piece. And if it's not black or white, then it's of course is just going to be a dot. That's how we represent an empty position here. Okay, so by the time this for loop is run, we now have built up all of the squares in our board. So now we can get to actually taking on our inputs and simulating the game. So let's say for turn in range int input. So we're going to run this for loop for as many times as our first input, which is in this case 4. So that's what this does here. It runs the for loop 4 times. And now we're going to simulate this. But before we do that, remember that our positions, our moves, are inputted as x, y, and direction. Except that x is a letter as opposed to a number. And we said earlier we want to only deal with number x's. So you have to convert x or the first character into the corresponding number. So how do we do that? Well, let's just say, let's create a string called A, B, C, D, E, F, G, and H. So these are all of the rows, or sorry, all of the columns, so all the x values. And we're just going to say that our x position is going to be equal to, we should probably take our input first, shouldn't we? So let's just call that move is equal to input. We're going to say x is equal to move, but the first character, but we need to change the first character to make sure it is a number. So let's take on our first character and then do a dot replace actually there should be a faster way. We can do a chars dot index that +1, and then convert that to, and then yeah, that should be good actually. Yeah, so line 15 basically just takes the first character of our input, finds its position in the char string that we created up here, and then we just have to add 1 to it. And we have to add 1 because Python 0 indexes, but our coordinate system starts from 1 in our code. What's y going to be equal to? Y is just the second value in our input, and it's a number, so let's convert that to a number. And then finally, the direction is going to be equal to the final character in our input. So now let's get to simulating this. So we're going to say if turn is odd or even. If turn is even, then it's white's turn, because white starts first, and therefore on the 0th run of the for loop when turn is 0, it's going to be white's turn. And what we want to do? Well, we want to change the current position. So we're going to change current x and y to a dot. So we're going to do board xy is going to be equal to a dot, because we're going to move the piece that's currently at that position. Where are we going to move it? Well, if it's white, we want to move it up the board, and so that means that our y value increases by 1. So we can do y plus equal 1. And how does our x value change? Well, it depends on whether we chose or whether the input was left or right. So x is going to be equal to itself plus 1 if the direction is equal to right. Otherwise, it's going to be equal to itself minus 1. So this is just another way of writing this if statement in 1 line as opposed to 4 lines. So the way you read this is by saying x plus equals 1 if this is true, and if that's not true, then we do x plus equals minus 1. So and x plus itself minus 1 is just equal to x minus 1. So yeah, this is how we're going to figure out the direction we want to go in. And then this would be where our piece moves to, unless there's another piece at that location. So if there is another piece at that location, i.e. if it is not a dot, then that means we've captured the opposition's piece and we want to do another jump in that direction. So firstly, if you've captured the opposition's piece and it goes off the board, so let's replace that position with a dot. And secondly, we want to move y and x another set. So let's just copy paste that code so we continue with another jump. And then once we've done all of that, once we've figured out our new position, we can finally add it to grid, like that. So this is the code that does the white's move for its turn. Now, if it's black, we can just copy paste all of that. Copy paste all of that and put that under an else statement, like that. And then we can change this white at the end to black because it's black's turn. We should also note a few things. So if it's black and black moves forward by going downwards. So we should do y minus equals 1 as opposed to plus equals 1. And the direction in which the left and right meet, what left and right means for black is different to what it means for white, because black is on the opposite side of the board. So white's right is black's left and vice versa. And so we should also ensure that we switch the right here to left, because if black is going left according to its left, then x increases by 1, right? Yeah, that's just how it works. And I think the question kind of hinted at this earlier on as well, because it says left and right refer to whether the piece move to its left or its right. Awesome. And this is pretty much the game done. Like we've simulated the whole game, and this seemed relatively simple. It wasn't too difficult, and the reason is because the problem kind of makes it easier for us. It says, well, firstly, the pieces, like every move will be valid, so we don't have to check for valid moves. Secondly, the pieces will never reach the end of the board, and so we don't have to deal with queening. Thirdly, just every move is valid, and because every move is valid, we can assume things. Like we can assume that there is indeed a piece at x and y, whereas the user might have incorrectly entered x and y. We're not going to assume that ever happens because we're told in the question that never happens. And so that kind of makes the problem a bit simpler. So once we finished doing all the simulation, now let's print our board to the screen. So we need to print it row by row, starting at row 8 and ending at row 1. So let's do for row in, or I guess for x, y, for y in range starting at 8, ending at 1, and therefore we go down to 0 in increments of -1. And then for the columns we do the basic 1 to 9. Awesome. And we just need to print that coordinate off to the screen essentially. So from board, we take that coordinate x and y and print that off to the screen. But remember, whenever you print something in Python, it automatically prints an extra line at the end. We don't want that, right? Because we want to print off a whole row at a time, like we see here, a whole row at a time, and then the next row. So if we add this comma end equals empty string to our print statement, it ensures that we don't print off an empty line. Because by default, the value is set to a new line character, and this is just the default. But we want to change the default, and so we have to explicitly say we don't want the new line character. But every time we have finished printing off a whole row, so every time the for loop on line 41 is completely run, like finished running, then we want to print off a new line character, because that's when we want to go to the next row, and therefore we need to repeat this whole process. And then if we submit that code, our simulation hopefully works, and our 43 lines of code get us 10 out of 10. No, 0. Okay. Let's do some live debugging. There's going to be some random issues in there. Grid is not defined. Oh yes, I made that mistake a lot, didn't I? No, just once. Okay, so I refer to it as grid as opposed to board. So let's fix that there and also there. And then submit that. Oh no, I'll do down here as well. Okay. Hopefully it doesn't time us out for taking too long. Let's run the code first to test it. Okay, yeah, that seems to be correct. Yeah, that's correct. Okay, so now we should get 10 out of 10. Yep, awesome.